Hello students, today we are going to study the third chapter of our class 9th science NCERT textbook, that is atoms and molecules. Now, atoms, what the term atom means. So, ancient Indian and Greek philosophers, they have always wondered about the unknown and unseen form of matter. So, they used to think that what is this unknown and unseen form of matter? The idea of divisibility of matter was considered long back in India, and Indian philosopher Maharshi Kannad, he postulated that if we go on dividing the matter he termed it as padarth, that if we go on dividing the matter, we shall get smaller and smaller particles. If we continuously divide matter, then ultimately a stage will come when we shall come across the smallest particles beyond which further division will not be possible. When we will continuously divide the matter, a stage will come when the particle will be the smallest one, and then further we will not able to divide it. So he named these particles as Parmanu, that is atoms. He named these particles as Parmanu, which we term as atoms. And then another Indian philosopher, he elaborated and said that these particles normally exist in a combined form, which gives us various forms of matter. Then another philosopher says that these atoms, these particles, they normally exist in a combined form and they give us various forms of matter. So, around the same era, around the same time, many ancient Greek philosophers, they suggested that if we go on dividing the matter, a stage will come when particles obtained cannot be divided further. That if they continuously divide matter, a stage will come when they will not able to divide that further. So they said Democritus, one Greek philosopher, Democritus, called these indivisible particles atom. So he called these indivisible particles, the smallest particles, he termed them as atoms. Then all this was based on philosophical consideration, but it was not experimentally proved. So when they did it experimentally, the experimental work was not too much validate. It was not validate, and then. But by the end of 18th century, scientists recognized the difference between elements and compounds. The scientists, they recognized the difference between elements and compounds, and they were interested in finding out how and why the elements combine and what happens when they combine. So Anton Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. Then Anton Lavoisier, he stated or he established two important laws of chemical combination. So this was the basic introduction about atoms and molecules, that how were these atoms formed and how were they recognized. So, the topics which we are going to cover in this chapter are laws of chemical combination, atom, atomic mass, atomic symbols, molecule, compound, atom or ion, valency and radicals, chemical formula, molecular mass and formula mass percentage, and mole concept. So now let's first study about chemical reaction. Basically, you know what is chemical reaction. Chemical reaction is, it is a reaction in which two or more substances react to form products. General meaning of reaction is mixing, right? Reaction means to react. So here chemically means here the reaction is taking chemically. So here it is reaction. In this reaction, two or more substances are involved to form the products. Example, if we take general example, A plus B, sorry, B gives A B. This is the general uh, we can say example. These are the reactants, the two reaction in which two or more substances we term them as reactants. They react to form products. AB we term it as product. This is a chemical reaction. Now, laws of chemical combination. As I told you that based on this Lavoisier and Joseph, they are the two scientists, they established two important laws of chemical combination. These two laws we will study in further, and they explained a lot about chemical reaction. So the first law is law of conservation of mass. According to this law, matter cannot be created, neither be destroyed in a chemical reaction. So, in a chemical reaction, matter can neither be created nor destroyed. So, this you have to learn it, you have to remember. If in exam it can be asked in 1 mark, state the law of conservation of mass. You have to write down, according to this law, matter cannot be created nor be destroyed in a chemical reaction. Okay, what happens in this? How can we simplify this if we want to understand it? That is, in a chemical reaction, the total mass of product is equal to total mass of reactant. As I told you, this is A plus B is the reactant. So the total mass of reactants, that is both the reactants, will be equal to the total mass of the product, that is AB. Though they are in different forms, though their forms are changing, they are reacting, and here it is giving us the result, but their mass will be same. Let's understand this with the help of an example. Okay, here 2H2 plus O2 gives 2H2O. This is a balanced chemical equation. This you will study in your higher classes, that is in your 10th you will study about this. So this is a balanced chemical equation. They have balanced it and written. You just have to find out the mass. So 2H2. So the atomic mass of hydrogen. First let me clear. H2. H2 is a molecule, hydrogen molecule, and only H is hydrogen atom. Similarly, if we write down O2, O2 is oxygen molecule, and only O is oxygen atom. Okay, here we have to consider the atomic mass of an atom. That is, we have to consider only atomic mass, not molecular mass. Okay, so here if we want to calculate the mass of both reactants and products, we want to see that whether they are equal or not. So how will we calculate? So first this is H2. We will consider only atom, that is hydrogen. Here two molecules of hydrogen are there, and here there are two hydrogen atoms, right? H2, so two hydrogen atoms, and here also 2 means we have to say two molecules of hydrogen. So the atomic mass of hydrogen is 1. Okay, it is 1. Here I am writing plus oxygen atom. So here two oxygen atoms are there. So the atomic mass of oxygen is 16, but here two oxygen atoms are there. Okay, just now we will write it as it is. It is 16. Then it gives us 2 H2O. H2, if we say one oxygen, one hydrogen atom is 1. The atomic mass of hydrogen atom is 1. Oxygen atom is 16. Okay, this is 16. This I am writing just now as it is. So here 2 are there. So 1 into 1 will be 2. 1. But here 2 atoms, 2 molecules of 2 hydrogen. Here it is 2 for hydrogen. Here also it is 2 for hydrogen. But the atomic mass is 1. So 2 plus 2 will be 4. It is 1. If we multiply it with 1, it will be the number as it is. So 2, if we multiply with 1, it will be 2. And this 2, if it is multiplied with 1, it will be 2. So 2 plus 2 will be 4. So this is 4 plus 2 molecules, 2 atoms of oxygen are there. So 16 into 2, it will be 32, right? This gives us H2O. Here 2 hydrogen molecules, right? 2 hydrogen atoms. This 2 plus this 2. So it will be 4, right? And this is 16. This also is 2. So here it is 2. 2 into 6. 2 plus 16 will be 18. For this 2 and for this 16. 2 plus 16, it will be 18. Multiplied into this 2. We have to multiply it with this 2. So it will be 36. So 32 plus 4, it is 36. This also is 36. So both the mass are equal. The total mass of reactant is equal to the total mass of product. I hope you are clear how to calculate the atomic mass. Okay, further we will do numericals based on this, but this was the basic explanation for you to get a basic idea, so that you will get a basic idea about atomic mass. Now, law of constant proportion. I hope you are clear with the law of conservation of mass. Now another law is law of constant proportion. This law states that in a pure chemical compound, same elements are present in definite proportion by mass and volume, irrespective of the method of preparation. So here in this law also you have to learn it. It can be asked in 1 mark. State the law of constant proportion. So you have to write down, according to this law, in a pure chemical compound, in a compound, the same elements are present in definite proportion, in same proportion of mass and volume, though their method of preparation is different, but the proportion, their mass and volume is same. So how? Let's study about this with the help of an example. If we take an example of in a compound such as water, if I take water, the ratio of mass of hydrogen to the mass of oxygen is always 1 into 8. Now from wherever we get water, either you can take it from wherever you want to take, either you want to take tap water, then river water, pond water, sea water, from wherever source you want to take, the ratio of the mass of hydrogen will always to the mass of oxygen will always be 1:8. It will always be 1:8. Okay, so thus if 9 gram of water is decomposed, 1 gram of hydrogen, so 1 gram hydrogen and 8 gram oxygen, 8 gram oxygen, okay, are always obtained. You have to always remember it. So if there is 9 gram of water is there, then it will be always be 1 gram of hydrogen and 8 gram of Oxygen, the ratio will be always 1:8. The ratio, mass ratio will be 1:8. Now, another example, if I take of ammonia, nitrogen, and hydrogen, it is always in 14:3 by mass. Whatever the method you want to obtain, it will be always 14:3. So, from wherever you prepare it, whatever method you prepare,